Download this code from codegive.com, link in the description below. Understanding shader compilation stutters in games. Introduction. In modern gaming, shaders are an essential component that allows developers to create visually stunning graphics. However, one common issue that many players experience is stuttering during gameplay, often referred to as shader compilation stutters. This tutorial will explain why these stutters occur, how they affect gameplay, and provide solutions to mitigate them. What are shaders? Shaders are small programs that run on the GPU and dictate how vertices and pixels are processed. They are written in languages like glsl, opengl shading language, or hlsl, high-level shading language. Shaders can be categorized into several types, with the most common being vertex shaders, fragment, pixel, shaders, and compute shaders. What causes shader compilation stutters? Shader compilation stutters occur when the game engine compiles shaders on the fly during gameplay. This typically happens under the following conditions. 1. First-time use. When a shader is used for the first time, the engine must compile it, which can take time and lead to noticeable frame drops. 2. Dynamic content. Games that generate content dynamically, like procedurally generated levels, may trigger shader compilation unexpectedly. 3. GPU memory management. If a game runs out of GPU memory, it may need to unload shaders and recompile them later when they are needed again. 4. Shader variants. Many games use multiple variants of shaders, example for different graphics settings. The engine may compile these variants at runtime, causing stutters. 5. Level changes. When transitioning between different levels or areas, new shaders may need to be compiled. Code example: shader compilation in a game engine. Here is a simplified example of how shader compilation might be handled in a game engine. This example uses C++ pseudocode to illustrate the process. CPP. Class shader. Public. Shader, const std string and source. / compile the shader from source code. Compile, source. Void compile, const std string and source. / simulate shader compilation. Std this underscore thread sleep underscore for, std chrono milliseconds, 100, / simulating delay. Std code shader compiled, source std and l. Class shader manager. Public. Shader asterisk gets header, const std string and name. If shaders.find name equals shaders.end. / if shader is not already compiled, compile it. Std code compiling shader, name std and l. Shader's name equals new shader, name. Return shader's name. Private. Std unordered underscore map std string, shader asterisk shaders. Int main. Shader manager. / simulate gameplay. 4. Const std string and shader name, basic shader, Fong shader, shadow shader. / this would be called during rendering. Shader manager.gets header, shader name. Return 0. Mitigating shader compilation stutters. To prevent or reduce shader compilation stutters, developers can employ several strategies. 1. Pre-compilation. Compile shaders during loading screens or at the start of the game instead of during gameplay. This ensures that all necessary shaders are ready before the player begins playing. 2. Shader caching. Implement a shader caching mechanism that stores compiled shaders on disk. This way, if a shader is needed again, it can be loaded quickly without recompiling. 3. Asynchronous loading, load shaders asynchronously in a separate thread, allowing the game to continue rendering while shaders are compiled. 4. Batching, group similar rendering calls together to minimize the number of unique shaders that need to be compiled. 5. Profiling and optimization, use profiling tools to identify which shaders are causing stutters and optimize them if necessary. Conclusion: shader compilation stutters can significantly impact the gameplay experience. By understanding the causes and implementing effective strategies to mitigate them, developers can create smoother and more enjoyable gaming experiences. Remember to profile and test your game thoroughly to ensure that shader compilation does not interfere with performance.